a little time. Yeah. So we have started recording, and so good morning everyone who made it this early on a Saturday morning. Your dedication is unparalleled. Welcome to today's Delhi JG meetup. I'm your host Steve Mann. I'm the leader of Delhi JG community and have been working with the community for more than 3 years now. During the days, I work as a backend developer at a startup called Farmlake. So that's about me. Uh, Next, we have our speaker Josh, aka Starbucks Man. Josh is a Spring developer advocate at Pivotal, and author of multiple books on real life Spring and a frequent traveler to raids of Java conferences and meetups around the world. He has a podcast called a Beautiful Podcast, which is quite a clever name, and he's also an active YouTuber. Also, I would like to mention that a lot of hard work goes into successfully organizing an event like this, and this for sure is not a one-man task. This event is no different. It's a result of time and effort given by a lot of people, which is really appreciated. I'll start with Delhi JG team. We have Vikas Malik with us. He's the leader at Delhi JG and has over 16 years of experience working with Java and related tools. We also have Gurpreet Sachdeva. Gurpreet Sachdeva is the founder of Delhi JG. He founded Delhi JG back in 2014. Gurpreet is a veteran with over 20 years of experience in Java and related technologies. And last but not the least, we have Mala Gupta with us, who herself is the first female Java champion of India. She works as a developer advocate at JetBrains.
Hi everyone, my camera is not working.
Okay. Yeah. So this event would not be possible without our outreach partners. We are calling them our reactive communities. And so thank you everyone. Thank you Mumbai JG, Bangalore JG, Hyderabad JG and Domino Code for all your support. It is much appreciated. And coming back to the focus of this event, we have this How's the Josh competition going on. What you need to do is just follow @DelhiJG on Twitter. Tweet about the event with the hashtag JL1020 and get a chance to win 1-year license for any one JetBrains product. So we'll be announcing the results by Sunday evening. So just go on Twitter and make some interesting tweet. The most interesting tweet wins. And you can follow us on social media. I'll be presenting this screen for you to scan this QR code at the end of the event as well. So over to you, Josh.
Me? Really? Oh,
yeah.
Oh my goodness. Okay. Let's see here, my friends. I shall clear my screen first. I appreciate that amazing introduction. I appreciate the opportunity to be here. I am so grateful for the opportunity. It's a weird year, but if somebody told me that, you know, I could travel to New Delhi and actually be with you all in person, and I could do so without worrying so much about that virus, then I would be there. I would be very happy to be there. I would be very full of good food once I got there. So I'm just a little sad. As happy as I am to be before you today, I'm just a little sad that it's not in person. But otherwise, just generally grateful for all of your time today. This morning, as he said, that's awesome. And to reiterate on what he said before, yeah, absolutely. These user groups take a lot of energy, so I'm always impressed when people put them on. And thank you for all that. It is good. It is good to see you all here. Good to see my friend and fellow Java champion Mala, who did you all see? She was in, was it Times of India or something like that, twice now in the newspaper. That's awesome, so awesome. So she's my hero, you know. So let's see, my friends. We have, I think, about 90 minutes or less, not very long, and we have a lot of stuff to get to. So let's do that. I trust that you can all see my screen. I wanted to just point out one little tiny thing. I'm no longer part of Pivotal, so the Spring team and the rest of Pivotal, we became part of VMware, and so I'm part of VMware now. But I work on the Spring team as always. I'm still in my capacity, as I've always been for the last 10+ years, a Spring developer advocate. I'm a Java champion, a title and honor I share with Mala, of course. And then I'm also a Kotlin GDE, a Google developer expert. And all that to say, I love the JVM. I think it's an interesting place to be and a more interesting place to write software. So I tend to talk about that kind of stuff a lot. I love the JVM. I love all the possible applications there. And so when I talk about stuff, I hope to inspire in you optimism and hope. But if I inspire questions and befuddlement, then there's my Twitter and there's my email, and I'm happy to engage. Don't hesitate to reach out. Like I said, we've got a very small, finite period of time in which we can hang out and engage. But that doesn't mean the conversation has to finish tonight or this morning, right? For me, it's actually 2100, 9 o'clock at night in San Francisco, in California, in the States. So feel free to reach out to me via either Twitter, where my direct messages are wide open and always accessible, or via email. Now, email is fine. Twitter's fine. If you had asked me a few years ago, I would have bemoaned email as a thing, as a feature. But now that I have no place to go and so much less to do, email works. It's fine. I'll probably get back to you pretty quickly. We have code here for your own leisure, for your own edification, for your own discretion later on. But like I said, the code is just it is the husk of the idea. It's not the actual idea itself. So note it for your own reference for later, but let's engage now, okay? I do work on the Spring team, as was just pointed out. I have some training videos. I wrote a book in 2017 called Cloud Native Java. I have a podcast called The Beautiful Podcast, which features, among other amazing people that teach me things, the amazing Mala Gupta. So she's on an episode there. And there's other people that are also smarter than I am who are like her, who have been on the show. So that's awesome. I encourage you to listen. Don't listen for me. Listen because of all the other amazing people that are on there. That's really what it's about. In my very privileged position as somebody who gets to bounce around and talk to these amazing people, I just feel I learn so much by just writing code with them or talking to them or having discussions. And I've always long since wondered, gee, wouldn't it be swell if I could just turn on the microphone? And so I did, and it's actually worked out quite well. I hope you will subscribe. I have a blog I write every Tuesday without fail since January 2011. It's called This Week in Spring, and it's just a roundup of all the news that's fit to reprint in the Spring ecosystem. Lots of stuff there, lots of stuff that you might find interesting. It's just new. It's blogs, news, videos, podcasts, whatever. Anything that tweets, anything that might be insightful. You might find that. And by the by, that also gets that's often bundled into a newsletter. So every month there's This Month in Spring, and you can find that blog on the VMware blog as well. I also have a Spring Tips screencast series every Wednesday where I just look at different parts of the Spring ecosystem, different bits of arcana in the Spring ecosystem, and it's just a deep dive, whereas most of my presentations tend to be roving, long, breadth first over depth first kinds of discussions. These are depth first, decidedly depth first. They focus on one particular thing. And I can do that because they're opt-in, right? You don't have to watch it, therefore it won't be a burden if you do watch it, right? Whereas with a conference talk or a general meetup like this, you hope for something, you hope to get something out of it, but if you already know everything about a particular topic, then it's a waste of your time, right? So I keep them breadth first for these kinds of things. And of course, I've got a new book, a book called Reactive Spring. And this book is, by the by, as far as I know, available on, well, certainly it's available on LeanPub, and it's also available for Kindle on Amazon India, and it's heavily discounted in certain markets, and I think India is one of them as well. So that's there as well. And that's, that's my t-shirt, right? That's what I'm wearing. I love it. I usually wear the Spring logo. Now it's reactive, right? So I've got the little, the halo of the energy or whatever around it. And we're going to talk about that today. So who knows? Maybe you don't even need the book. You might get everything you need out of the next 90 or so minutes or whatever we've got left. And that's to be expected, right? I hope you get everything you need out of it. So let's talk about reactive programming. Let's talk about reactive programming in general. And by the by, friends, we're just going to talk. I'm not going to move the screen. There's no slides. We're just talking for a few minutes, okay? So if you don't see the screen move, don't fret. It's okay. Everything's fine. We're just talking. Were this a normal conference where I could actually talk to you in person, I would stand at the tip of the stage and we would just talk, and there'd be no movement, and it'd be very clear what's happening. But I find now, where everything has gone virtual, that sometimes people become nervous when the screen isn't moving, when it's not animated, right? So we're going to talk about reactive programming. Reactive programming is a fairly old solution to a fairly new problem. This solution, this idea is we want to write software that solves two use cases that haven't hitherto been very well solved. The first use case is I want to make better use of the resources in my system that limit my ability as an engineer and architect to scale, right? And when you think about what things constrain your typical Java microservice these days, well, there's obviously two major factors, right? Your ability to do CPU-bound work, so Fibonacci series, cryptography, Bitcoin, that kind of stuff, and your ability to do IO-bound work, right? These are it. This is basically what you're going to struggle with at this point, right? RAM really isn't the problem, right? How much you can address in Java, that's still a problem. But really, that's not the architecture most of us are building. So where we might have a lot of something is in the computation, could be, or in the input and output. Computation, I'm afraid, there's just not much I can help you with there, right? In computation, you can get a faster CPU, you can check out the new vector API in Java 16. Lots of things you could do to make your computation faster. That's not what this talks about. What we want to look at is ways to make our input and output more efficient, more useful, more productive. And in order to appreciate why that's a use case, let's consider the traditional approach to building input and output on the JVM. Traditionally, we use Java IO input stream and Java IO output stream. These types are fundamental. They're everywhere, right? And so while Java NIO, java.nio.asterisk, has been in Java since 1.4, which, February of 2004, long time, right? 2002, sorry, 18 plus years. February of 2002, 18 plus years it's been in the JDK, and yet most of us don't use that. So the Java IO input stream is a simplifying abstraction. It's a very simple thing to imagine. Imagine you're trying to read data from some sort of stream, a source of bytes. So you say, while input stream.read does not equal -1, you read the byte into a buffer, and then you work with it. And you can accumulate the buffer, or you can just process it and forward it onto something else. You can do all sorts of things with that buffer. But as you're doing so, as you're reading from that input stream, you're waiting. You're sitting there on the client thread, which is usually your main thread, or perhaps in a web server, it's a web server thread, and you're waiting for the result. And the result of that is that you're sitting on the thread, and that thread is inaccessible to anybody else in the system, to anything else in the system. That's where we get into trouble. Because you see, friends, threads are expensive. They cost a lot of RAM, they cost a lot of bookkeeping to create more threads. And this is problematic because we can't create an infinite number of threads. This is the first problem, right? Hopefully, in the not too distant future, in the next year or so, Project Loom as part of Java 17 will drop, and then we'll have the ability to create more threads. That gets us part of the way. Then we have another problem, which is the one that I think is far more interesting, which is data flow. Okay, so how do we describe, once we've got the ability to handle more requests, once we've got the ability to create more threads, how do we describe our data flow, right? I don't like to actually write code that assumes that I can just sit there on the thread and wait for the next byte, right? Because that's not the reality of the world. The reality of the world is that data will come when it comes. It's asynchronous. There might be errors in that asynchronicity. There might be latency implied in that asynchronicity. And as an engineer, I want to be able to write code that accommodates that reality, right? This becomes more salient, more important, more relevant when you start building microservices, when you start building distributed systems in which the interchange of messages, of data from one node to another becomes paramount, right? So now I start thinking about the world in terms of input streams and output streams, and suddenly I don't feel like I've got as much control over the situation as I should perhaps have. This becomes, as I say, very important when you start building distributed systems. So we need a program model that allows us to describe the reality of asynchronous, potentially latent, potentially unbounded data flow, right? And so for this, for these two use cases, we have reactive programming. Reactive programming is not a new thing, as I say. We've seen, Eric Myers working on reactive programming over at the Rx extensions for .NET, right? This actually originated in the .NET space years ago. And so this was one of those things that was born out of that. And then in the Java space, you see things like Rx Java, and then, of course, Project Reactor from the Spring team, and Akka and Akka Streams from Lightbend, and Vertex from the Eclipse Foundation, and all sorts of interesting projects that all sought to sort of provide a common ground approach to describing latent, potentially available, potentially asynchronous reactive streams. These types were born into the reactive stream specification, a default sort of de facto standard that gives us 4 very simple interfaces. Foundational interfaces, to be clear, they're very, very succinct, very simple foundational interfaces. They're so obviously useful, though, that they are part of the JDK. They're actually in Java 9 or later. So Java util concurrent .F flow .*. They're the beginning, but I think that they still fall short for many of our use cases because they only imply a way to describe asynchronous data. They don't really give us operators that allow us to, in the way we might with Java 8 streams, process that data, right? So things like map and filter and flat map and so on are lost to us. These opportunities are foreclosed by these very limited interfaces. This is where projects like RxJava, like Akka Streams, like Reactor from the Spring team, and like Vertex from the Eclipse Foundation can fill the gap, right? They provide implementations, specializations of these types, and they give us these extra operators in a whole way, a whole paradigm in which we can describe asynchronous data flow and to process that data. That's very important. But even there, I would say that you're still not ready to go to production, because as interesting as it is, I think we've gotten no further in all of this than a sort of asynchronous, non-blocking reactive equivalent or analog to a Java collection. Can you build your web services and do your data access logic and do security and all these other things with just collections? Certainly not, right? I mean, I suppose you could, but you'd be spending a lot of time reinventing a lot of code that need not be so reinvented. So we have then a use case. We need to build something. We need to have something that allows us to build a better bread and butter software that allows us to deliver value into production. Enter Spring. And so in 2017, the Spring team took its first big step into the reactive world because you see, while we developed Reactor and while Reactor has been around since 2011, it wasn't officially integrated as part of a top-level API for Spring until 2017, Spring Framework 5. But things have progressed considerably since then, friends. Since then, we've released Spring Framework 5, Spring Boot 2.0, Spring Security, Spring Data, Spring Cloud. All these different projects, these umbrella projects or portfolio projects, have since been updated to accommodate reactive programming. And that, my friends, is the journey that we're going to walk today. We're going to see how these things play well together, how they integrate, and how they allow us to build better, more sophisticated, more robust, more resilient reactive systems. What we're going to see, my friends, is that reactive APIs give us 3 things. They give us a more consistent interface with which to integrate different APIs, right? That is to say, they better support composition, which is, again, very useful in a distributed world. They give us more resource-efficient APIs. So that is to say, they give us code that actually performs better. We can cut down on data center spending, right? They can give us the ability to do more with less. Always a nice thing to have, even in the world where we have unlimited warehouses full of computers at our fingertips in the cloud. And then finally, they give us a way to write more robust or more resilient services, right? And all of that, you get all of that while not having to do more, right? You actually learn less, right? You can actually forget or unlearn a whole bunch of other stuff as a result of this. And if you don't know the other stuff, congratulations. You don't need to now, right? Because you're going to have actually one API, one unified approach to dealing with anything that wants to give you data eventually or asynchronously, right? So let's go to start.spring.io, and we're going to build a brand new application. We're going to build an application called, imaginatively enough, Service. Now, we're going to go here and we're going to build an application. And we could choose, we could linger and specify some of these dependencies, some of these defaults. Obviously, any of these languages would be just fine. Groovy, Kotlin, and Java are all great choices, obviously. We could use Maven or Gradle. Again, it's up to you. The choice of Spring Boot here is, I think, pretty interesting. We're going to use 2.34 for our time together. But that said, keep in mind, there's actually a lot of really good stuff happening in the milestone versions of 2.4, right? 2.4 M4 is out, apparently. That must be recent because I was just using M3 the other day. 2.4 M4 takes Spring Boot's position and its relevance in the cloud, its position of dominance in the cloud, even further. It further cements that position. And it builds upon the foundations that we laid in Spring Boot 2.3 to more natively support Kubernetes-based applications. So In Spring Boot 2.4, we have, in 2.3, we have a number of features, including readiness probes. That is to say, when you start up a container in Kubernetes and you want to be sure that the service is ready to start serving traffic, there's a native endpoint now built into the Spring Boot actuator to address that. Spring Boot 2.4 also has availability probes, which is a bit like the Spring Boot actuator health endpoint, except that it's in a particular mechanism. It's a particular mechanism that Kubernetes will know what to do with, and it speaks to the health of the service. We also have the ability to build Docker images just out of the box. It's just part of the Maven plugin now, and that actually uses a project called Paquetto. So Paquetto is a project from the Cloud Native Computing Foundation that gives you a way, given an application artifact, be it a Java application, an Nginx application, Node, Ruby, PHP, .NET, Go, or any of a number of other ones, because this idea of a build pack originates not from the Cloud Native Computing Foundation, but from Heroku and then Pivotal and the Spring team and Cloud Foundry and so on. And this mechanism is a very simple thing in the abstract. It's a thing that you can give your application artifact to, and it'll set up everything needed to run that application. It'll create a sensible file system that has all the sensible defaults that you need to run that given application. So, for example, for the JVM, it'll set up a JDK and maybe any Java agents if you opt into some of those security or monitoring tools. Right? There's flags that you can use. For PHP, it might set up a web server or download the embedded web server or whatever, right? For Ruby, it might set up the Ruby runtime and so on. The .NET might set up the .NET CLR and do all sorts of things, including expertly decide how much RAM and what memory heaps and memory pools should be assigned to each of these applications, right? So, for example, for Java, we can sensibly set some defaults for all the different things that server-side Java applications tend to care about, as opposed to just XMX, right? That's not the only thing you should care about. And these build packs take all that, create a file system that has everything needed to run this application, and then they create a Docker image, a Docker container, an OCI image. And you can then push that image to your container registry and deploy that to Kubernetes or Cloud Foundry or Mesos or whatever, right? So really, really valuable infrastructure. And the benefit of this, of course, is that you have a sensible default. You just give it a Spring Boot jar. That's it. And the next thing you know, you've got as production ready as it's going to get container, right? Obviously, that doesn't excuse you from having to address things like security in your application code proper. But in terms of getting a cookie cutter sort of container out of the process, it couldn't be easier, right? So Spring Boot embeds Paquetto. It's actually a thing that you can use out of the box when you use Spring Boot. It just works for you automatically, right? So you can create a new container by saying Maven Spring Boot :build -image, and that's in Spring Boot 2.3, right? So I like that. I like all these Kubernetes features. There's another thing that's in there. It's Graceful Shutdown. So you can actually tell Spring Boot when the application is asked to shut down. For example, in Kubernetes, when a pod gets killed, but you've got in-flight transactions, it's very useful to have Spring Boot stop serving any new requests, but then drain for a period of some configurable interval, maybe 30 seconds, for example, any existing in-flight transactions. All that is supported out of the box in 2.3. In 2.4, we go a step further. Now we have support for Kubernetes config maps, and we have really good integration with the Spring GraalVM project, the Spring GraalVM native project. And this is one of the things that I really like, right? So now I have a Git repository here that you can find, right? Go to mygithub.com, and it's Josh Long, WebFlux Actuator GraalVM. And here, I'm not going to spend all this time compiling it because it does take actually several minutes, but what you need to appreciate in order for this to work is that the application itself, let's see here, .java, is just a regular stock standard Spring Boot application, and there's a proxy bean method equals false. That's the important bit there. That's the impact to your Java code. Everything else is just this is just a reactive application. We'll see all this stuff in the course of our time together today. But you could do the same with a Tomcat, a Spring Data, JPA, and Tomcat, and Hibernate, and whatever. Same thing, right? You do this, and then you have 3 different mechanisms you can use to compile it. One is you could just say, once you've added this dependency here, once you've added that to your build, you can use this not yet GA, very early days project, once you've added that to the class path, then you can do one of three different things. One, you could just say, I want to, in my Spring Boot Maven build, configure the Paquetto build pack for native images. That could work. That's one way to get a native image out of this. Another thing you could do is just to compile it yourself, right? Here's the actual compile.sh, which builds the jar, uses Maven clean package, unpacks the jar, gets all the libraries into a file that the native image command in GraalVM will know about. And that works just fine. And we'll pass in these two flags that you need, right? That's another thing. And then finally, what's the other one? I don't even remember the other one. I'm sure there is another one, but there's a third one. It doesn't matter. Point is, this approach gives you a native image. And what I mean by that is there's this library called GraalVM. GraalVM is a C1 Java just-in-time compiler replacement. Okay, so in your JDK, OpenJDK or whatever, you can replace the just-in-time compiler, hotspot, right? You can replace that with something. GraalVM was intended to be a Java just-in-time compiler that was implemented mostly in Java, if for no other reason than to simplify the implementation and to remove some of the considerably spaghetti-like code that had been there since the 90s. Okay, so GraalVM is awesome, really, really interesting, and it's one of those things where if you're a large organization, ignoring all these other things that people are talking about, like native images, it's still very, very fast, very, very performant. So it's worth your time if for no other reason than that. But one of the things that fell out of this project was the insight that, hey, if we have a thing that can analyze the hot paths in your code base and turn them into native code where appropriate, what's stopping us from just making everything native code, right? Everything in the application could be turned into native code. And that's called an ahead-of-time compiler. In the Java community, right, it's an ahead-of-time compiler. You're going to sound very silly if you go to any other language at all that has a compiler and say, hey, I'm using an ahead-of-time compiler. Because for everybody else, compilation just means compilation. We've got this thing where you take bytecode and turn it into, we take source code and turn it to bytecode, and we call it compilation. So we had to create a new word to talk about what happens when you take bytecode and turn it into a native image, but everybody else just goes straight to the native image. So awkward. But anyway, ahead-of-time compilation just means compiling to the hardware, right? We're creating a hardware-specific, architecture-specific binary. And the result is something that takes much less memory because you've shed the JVM. And it's also something that starts up in very little time, right? For other reasons. This binary, very useful in a cloud environment, as you can imagine, right? Very resource efficient, very small, very lightweight, and very fast. So we've got this support here. It's milestones. It's not yet GA. None of it is GA yet, but it works, right? So I've already run this, or I've already compiled it. There's my native application. Let's try that again. Okay, you can see it takes a little while to shut down because of Graceful Shutdown. Okay, there it is. So here's my native application, and you can see that this application has Graceful Shutdown. It has actuator. It has I'm talking to an embedded SQL database. Not only am I talking to a database, but I'm actually running the database in the process itself. I'm actually embedding a whole SQL data store, and I've got a web endpoint, and I've got my Spring Data ORM implementation. That's in 0.13 seconds, right? It's like 13. 13% of a second, right? Basically. So not bad. Really, really not bad. Your numbers will likely be faster if you don't embed the SQL data store, right? So I think it's worth your time. I think you should try it out if you can. But that's neither here nor there. That's not why we're here, friends. It's not what I wanted to talk to you about. What I really wanted to talk about was reactive programming. I'm just so stoked about what 2.4 portends for the average developer, and I think it'd be worth a whole other discussion perhaps next time. Okay, so we're going to build a service. We have down here one last choice to make, friends of mine. We have one more choice we have to make. What version of Java do we want to use in 2020, nay, almost 2021? We have before us 3 checkboxes, but really only 2 choices. 2 choices. 3 checkboxes, just 2 choices. We have here on the right Java 8. This is what I call a non-choice, and that's not just a brand, friends. It's a choice that you cannot make, you should not make in 2020, nay, almost 2021. Ignore this. Do so not because I told you to, but because you know that you should ignore this. This is a technically inferior version of Java. It's inferior in every way. It's less secure, less performant, less robust, less featureful. It's just a terrible choice, technically. It's also morally a terrible choice. What do you think the conversation is going to look like, or it's going to go? What do you think the conversation is going to be when you tell your children that you're still running Java 8 in production? How do you think they're going to respond? It's not going to be good, trust me. The look in their faces, as their faces crumple in disgust at what you've just told them, the pain is indescribable. So don't do it. Do the right thing, friends. Use the current long-term supported version of Java, which is Java 11, or better, use the current version of Java. I like Java 11, it's fine, but Java 15 is really, really great. It's really great. And if you're in a cloud platform, it's trivial to just conveyor belt your application to the next version of Java anyway, right? Every 6 months. Obviously, if you're using build packs, it'll be very trivial to just move to the new version once the build pack gets updated. You update the build pack, and all your applications benefit from that, right? So there's lots of benefits that I'm going to use Java 15. Not that any of this stuff that we're going to talk about requires Java 15, but because I can. Okay, so I've got my selections. I'm going to bring in the reactive web support. We're going to bring in Lombok. We're going to bring in R2DBC. We're going to bring in PostgreSQL. And I think we're going to bring in RSocket. And perhaps, just perhaps, Spring Security. Now, I'm satisfied with my selections, but that said, you know, yours might be different. And we're going to hit Generate. And once we've generated our project, we're going to open it up in my IDE. So Downloads. And I've got a little script here. Let me get bigger. I've got a little script called UAO. It's unzip and open. All I've done is unzip that zip file and then told IntelliJ IDEA to open up that particular pom.xml. Okay, that's it. Here we go, loading the project. Let me make my font a little bit, my screen a little bit bigger. Okay, hopefully you can all see that better. Okay, so we have a new application. Point it to the right, JDK. Go. All right, good stuff. So there's our new application, and we're going to comment out some of the dependencies that we don't need just yet. Okay. I've already told you we don't need security just yet. We might not even get to it. Who knows? We'll see. So comment that out. And this bit here. Good. Okay, so what we want to do is we want to build an application that writes to a database. And so because we're going to be using reactive APIs, I have chosen to talk to a SQL database using R2DBC. This is the Reactive Relational Database Connectivity Abstraction. And I've chosen to use an implementation that supports my database of choice, which in this case is Postgres, right? So I can just bring in the right driver there, R2DBC PostgreSQL. Remember, this is not JDBC. JDBC is an API that assumes the presence of something like Java I/O input stream, right? And because it does, the API reflects that that useless default. So what we want is to have something that optimizes for asynchronous I/O, Java NIO. The idea that I'm going to ask for bytes and then jump off the thread and have something register a callback for whenever those bytes are available. That callback, that interrupt, is what my code will use to decide to go back into action. But we're never just going to sit on a thread waiting for the next byte. We're going to relinquish that thread and return it to the thread pool for something else in the system whenever we can. So we waste no time at all in between the raindrops, in between bytes, just doing nothing. Okay. Now, here's my R2DBC Postgres driver. There are many other R2DBC implementations for, among other things, SQL Server, MySQL, MariaDB, H2, SAP HANA, I mean, all sorts of stuff, right? There's also a number of reactive NoSQL data store implementation. So you can use Reactive Cassandra, Redis, MongoDB, Couchbase, Elasticsearch, Neo4j. Am I missing? Oh, Google Cloud Spanner, Azure Cosmos DB, and I'm sure I'm missing a few, but there's just a seemingly endless list, and you can find more if you go to start.spring.io. So I'm happy with those. What I'm going to do now is I'm going to build an application that has a field, right? It's going to have an integer, a primary key, monotonically incrementing primary key, and a name. Okay, so this is the essence of what I want to express. I'm going to make this an ID at data, at allargs constructor, and at noargs constructor. Right, so I'm just creating a basic entity. If I had enabled a preview feature, I could use records, and that would have made short work of what I just did, but we still need this, right? Okay, so now I've got this entity, and I want to persist it into the database. So I'm going to use a repository, a Spring Data repository. And this repository is going to extend the Reactive CRUD repository. So Reactive CRUD repository of Reservation, whose primary key is of type integer. Now, a repository is just an interface that's applied in the Spring Data project. It provides a number of methods that support just your basic soul-annihilatingly boring data access lifecycle, right? So save all, find, count, delete, etc. These signatures, I don't think all that surprising, but what might be interesting to you are these types that are accepted, the first of which is a publisher. A publisher is a thing that publishes data asynchronously out of band to a subscriber. A subscriber can then consume the data, and when the subscriber first subscribes to that publisher, it is given a subscription. The subscription is super important, so we're going to double click on that in just a second. But first, let's address these last three methods. When the publisher produces data asynchronously out of band for a subscriber to consume, it does so, and it is consumed here in the onNext method. When there are errors, when ineluctably there are errors, those errors are registered here in the onError method. And finally, when the subscriber has finished when the publisher rather has finished emitting all the data it's going to emit, the data arrives here in the onComplete method. Now, I said we're going to talk about the subscription, and we should. Let's return to this. This subscription is arguably the most important type in the whole, the whole de facto specification. Remember, this is a reactive streams type. Remember, I talked about that set of 4 common ground interfaces. Here we are. This is the beating heart of that API. The subscription is given to the subscriber. The subscriber is given a subscription, and the subscriber can use that subscription. It can keep a reference to that subscription, and it can ask for more data. It can say, I want 1 record, or I want 1,000 records. If it says, I want -1 records, it'll just get all the records that are available, right? It'll just keep, the producer will just keep sending data. What's important here is that the subscriber can say, I want 1 record, and then it can say, I don't want anything. It can just not ask for any more. So the subscriber controls how much data it has to deal with, how much processing it has to do. It controls the rate of consumption. That's super important when you build a distributed system, right? I want one side to not be able to overflow the other. This is not a novel idea, not a novel thing, not even close, right? It's a thing with which we've had to contend ever since there was one computer on the same network as another. We had to think about what happens when one side moves faster than the other, right? So all we've done is we've surfaced that in this API. Now at a top level, in a top level type, we can say, I want to request 1 more record, 1 more byte, 1 more string, 1 more customer object, 1 more whatever, right? It doesn't matter. I can request also 1 billion records if I want. It really only depends on how much I feel I can handle in one fell swoop, were it all to be dropped to my lap at the same time. So if I request 1,000 records, I'm signaling that I am prepared to process 1,000 records and I won't get overwhelmed, right? So it's really up to you. Let's say I decide that I've just had enough of these records and they're nothing but trouble and I want to be done with them. I can call subscription.cancel. And with .cancel, I'm saying I'm just going to abandon the whole process. I just don't want to talk. I don't want to do anything. I'm moving on, okay? So either way, the subscriber is in the driver's seat here. The subscriber controls the rate of consumption. That's very important when you build distributed systems. I did say that there are 4 types, didn't I? There's 4 types. Well, there's also a processor. The processor is a bridge. It's a source and a sink. It's a publisher and a subscriber. Very simple, right? Data in, data out. It just acts as a bridge. Now, these types, as I said, are so useful, so very useful, that they've since been incorporated into the JDK. So here they are: Java, UTL, concurrent, flow, dot processor, dot subscription, dot subscriber, and dot publisher. Okay, so they're all there now. Now we have these foundational types, but I did say that they were sort of Spartan. I think you'll agree, having just seen them all. So for that, we have Project Reactor, and Reactor provides 2 specialized types. The first of which is a mono. A mono is a publisher that produces 0 or 1 record. That's it. By the way, that flow control we talked about earlier, when I talked about the subscription and all that stuff, that's sometimes interchangeably referred to as back pressure, okay? So you might see that on the marketing, but it means flow control. So a mono is a publisher that has 0 or 1 records, so it's a bit like a completable future, except that it's got back pressure, right? Very convenient. Also, it's got everything else, lots and lots of everything else, lots of stuff, right? Filters go lower, things like map and flat map and filter and you know, all these different operators that you can use to aid your work in composition and so on. Lots of good stuff there. There's also a Flux. A Flux is a publisher that produces 0 to n records, where n is potentially unbounded. It could be 1, it could be 0, it could be 5, it could be a billion, it could be infinite, right? As long as your computer is still processing it, right? A Flux is just another publisher, and it, again, very rich, actually richer. There's even more types here. Look at that. 2270, that's a lot. So we have 2,270 lines of operators, which is, I hope, a reminder or it implies something very important, which is, as simple as those interfaces are, you should not try and build your own. You shouldn't. Don't do it. Wouldn't be prudent. You're not going to get far. You'll end up wasting 1.5 years of your life, and you will have something that is far more buggy than just using this, right? So what we're going to do is instead just build upon these abstractions and let Spring and Reactive do the work for us. So I've got now this repository, and what I want to do is I want to create a sample data initializer. And this is going to just be a regular Spring bean that listens for a ready event, and we're going to respond to that ready event when the application starts up, right? And so we're going to use the just created repository here, and we're going to inject that into the constructor like so. Now this repository, I want to inject it into the constructor of my object. So I'm going to synthesize a constructor using Lumbach's very convenient, very handy required args constructor. And what I want to do is I want to write some data to the database. So I'm going to write the names of some folks on the Spring team. Okay, so I'll use this builder API to write some names of people on the Spring team. So Madhura, of course, she's legendary. Ilya, he's legendary. By the way, you know who Ilya is? I should Spring.io team. I don't know how to. I know I could figure it out if I tried. Did I miss something? One, two, three, four, five. Do we not have him on this website anymore? Or was he never there? We should have him. What's that sound? What? Huh? There he is. There. We just call him Ilya. He's the best. I just don't know how to pronounce the whole name. Okay, so paste. Okay, and who else is on the Spring team who's amazing? We've got Stefan. We've got what was that? Would you please mute yourself if you can? I appreciate it, friends. Okay, so we've got who else? Stefan, and who else do we have? Dr. Sire, the good Dr. Sire, one of my favorite doctors, along with Doctors Who, Subramaniam, Strange, and Seuss. We've got. I'm on the Spring team. I count, I guess, so that's pretty cool. We've got Violetta, she's legendary. We've got Olga, she's legendary. We've got Yushin, she's also legendary as well. So lots of engineers in the Spring team. Okay, so now I'm going to visit each one of these names and turn them into a reservation, like so. And what that's going to give me is it's going to give me a reactive stream of reservations. Whereas before, I used auto types, and you couldn't type inference, you couldn't see it. But before I had a stream of strings, now I have a stream of reservations. And these are just in memory, right? There's nothing that's been committed to memory just yet, or to my database yet. So what I want to do is I want to say, I want to map and visit each one of these reservations and use the injected repository like so. The problem, however, is that .save returns a mono. So what I get is a lambda that returns a mono. And I've got map, which of course is a container. It'll aggregate all the results of the lambda into a container type, which is yet a flux. So I've got a flux of mono of reservation. Not good, right? That's too much. I've got a flux, I've got a mono, I've got a reservation. I just want. Huh? Please mute yourself, friends. I've just got I want a flux of reservation. And so what I'm going to do is I'm going to flatten the nested asynchronous types. I'm going to flatten the type that comes from this and create a view of the inner asynchronous types by using flat map. So you flat map your stream, then you flatten the curve. These two things are very important in 2020. Okay, so I'm going to save the data, and now I've got data being written to the database, or do I? Right? The question, of course, is if I have saved, has anything actually been committed? If I were to go to my database at this point in the execution in the running program right here, would anything be in the database? And the answer is, of course, no, because this is a inert type, right? It's inert in that you have to actually force it to do something. Think of it like a faucet or a pipeline through which water will flow. I haven't turned on the faucet, and therefore there's no water flowing through the pipeline. In the same way that when you use the Java 8 Streams API, you need to have a terminal method invocation like .for each. So I'll say saved.subscribe. And here, there are a number of different overloads. You can use whatever one you like. But I'm just going to print out the results using a lambda. Okay, so that'll create the whole pipeline. But keep in mind, this is tedious. Look at all this. I've got these 3 different stages, 3 different variables. I don't write code like that, friends, and you shouldn't either. So what we're going to do is we're going to take that, string them together, woo, and put them into one little pipe. Okay, there we go. Much easier to grasp and to follow and to work with. So now I've got these names, and when I visit each of these names, it'll print out the results. That said, I'm not quite ready to do that, because consider what's going to happen. We can gaze into the crystal ball here and just kind of use our imagination. What happens if I run this program one time? Well, hopefully, if everything has gone to plan, then we'll see all 8 names written in the data store and reflected very quickly. Okay, the second time, well, we'll see 16, and the third time, 24. You see the problem here, friends? We're going to have duplicative data, and I don't want duplicative data. So what I want to do is I want to say repository delete all, and then I'm going to say I want to find all the records, and then sorry, well, actually that's what I want to do. I want to do that, but I want to save the data first. So I'll say then names. So now I've defined yet another pipeline, and in this pipeline I'm actually doing something that has a deterministic behavior. I'm saying I need everything to be deleted first. This delete all returns a mono. It's a reactive type. And so after this is executed, potentially, by the way, on a separate thread at a separate point in time, after that is executed, then I want to write all the names to the data store. And then finally, I want to find all the data in the database. And then finally, again, I want to print out the results. So all these things happen one after the other, and I'm guaranteed of that. And yet you don't see me fiddling with executors or runnables or phasers or countdown latches or cyclic barriers or any of that nonsense to get this deterministic and yet concurrent behavior. If it needs to be concurrent, it can be, right? So for example, in this code here, there's no reason that the runtime couldn't take all 8 of these and just write them all to the database at the same time, right? If I wanted to enforce that, I could use an operator like flat map sequential, right? In which case I would be forced to sequentially write things to the database. But there's all sorts of opportunities for the runtime to do these kinds of things for us more expeditiously, more efficiently. Okay, so now I've written this pipeline. I'm deleting everything. I'm writing the data to the database. Then I'm querying the database to get everything back and just to see that reflected in the console output. Let's go ahead and start application and just see if it worked. You know, who knows? It's complaining that I haven't specified a connection string. Good point. So in Spring Boot, you go to application.properties, Spring r2dbc.url, r2dbc Postgres, localhost, host, orders, okay? And username, orders, and password orders. And voila. Okay. There's my connection string. I'm telling my application to what database I want to connect. It spins up and it reflects the output in the console here, right? So there we go. We can see everything's worked just fine. It's there. And we can go to the console here, PSQL, view orders, select all from reservation. And there we are. We happy few, all 8 of us. It worked. It worked, my friends, and that's okay. And by the way, you might notice, as I said earlier, you might notice they might be out of order, right? You don't know. It's not really, yeah, Josh showed up, seemingly at a different time than Yushin, right? So again, because the runtime doesn't, it's just trying to do things as quickly as it can, right? So we get benefits from that. We've gotten data in the database. Congratulations, right? Obviously, not a huge deal. The question, of course, is, well, suppose I wanted to build a fine-grained service, okay? Well, I can build a service. So I say class reservation service, and I'm going to register, I'm going to create an endpoint that, given a variadic array of strings, will write data to the database, okay? And I'm going to just improve upon the basic approach that I've already outlined in the initializer there. And this is just going to be a thing that uses the reservation repository to do this work, right? Learning from what we just learned here. So instead of this, I'll say from an array, array, and I'll pass in the names, names here, results, okay, and otherwise, it's basically the same. So I can return this, and I can say return names. Now, think about what I've just done here. I want to return a flux of reservations. Why is it not happy with me? String ... names. This gives me a result. Cheers, thanks. Go compiler, go. Okay, so I've got a thing that's going to write data to the database, and that's just fine. So suppose I call this endpoint and I rewrite my code down here to instead defer to that newly minted service. I say reservation service, and I remove all this and I remove all that, and I say this dot reservation service dot save all, and now I've replaced it with that. What I've got now is a new reactive stream, and everything's fine. But I want some sort of consistency here. I want to guarantee that if I write data to the database, that either all of it gets written or none of it gets written. Suppose I had some sort of validation in there where if the name is lowercase, if it starts with a lowercase letter, it doesn't get written, right? So I could say do on next reservation. Here, I want to assert certain things about the state of the name. I'll say get name dot car at 0 has to be uppercase, and I can of course use the very handy character is uppercase to confirm as much, right? So I like this approach. The name must start with a capital letter, right? Very simple. Now, remember, I've already written the data in this case. I'm doing the validation after I've written the data. And even if that weren't the case, I would still want to unilaterally either write all 8 names or 0 names. I don't want 7 or 5. I want deterministic state. So obviously, this is a use case that screams for transaction demarcation, right? So I'll use @transaction in Spring, and that works. And that's the important bit here, friends. That does work, but consider why it works. Why would that work? Think about what normally happens when you use something like @transactional, not just in Spring, friends, but almost anywhere, right? What happens behind the scenes for something like that to work? We start a transaction for you automatically at the beginning of the method before invoking this method, right? And then so how do we know what transaction corresponds to the current executing method? Traditionally, we knew because we stored that transaction in the thread local, and the assumption was that you weren't going to jump from one thread to another. Well, that goes out the window now, doesn't it? We can't make that assumption. There's absolutely no guarantee whatsoever that the thread on which we start processing this response will be the same one as the one that we use when we're done processing this response, right? That's no longer a fair assumption, and so we can't rely on the thread local anymore. That no longer holds up. So the question then is, what can we do in Spring and in Reactive APIs to propagate state for the life of the reactive pipeline as opposed to for the life of the current method on a current thread? And to support this use case, we have something called the subscriber. So context of key value. Think of it as just a dictionary, except unlike a thread local, it supports multiple values, right? Thread locals are basically a map with one entry, which is a mapping from the current thread to a value, right? The context can help. It's just a dictionary. You can hold as many values as you want, and it lives with the pipeline. It lives for as long as this pipeline is executing. And so if in the framework code, we want to do something like adding, I don't know, the transaction, before you invoke this method, it creates the transaction and associates it with the current pipeline, right? Or rather, before it invokes the pipeline.
Josh,
Yeah.
sorry to interrupt. I think something happened with the share. Can you stop and share one more time? Because I think it messed up in the screen. It's not showing up.
How long has it been not showing up?
Just a second.
Oh. Resume your presentation. Oh, what's going on? Resume presenting. Are we okay now?
Yes.
How awkward. I'm sorry about that.
Thank you.
How far should I go back?
I think you're fine. It was just a second ago.
Okay. Apologies for that. I'm not sure what it could have been. Oh, is it because we're at the top of the hour? That might have been it.
No, not really. Maybe someone accidentally started presenting, and that's why they steal the share. So,
oh, okay. Fair enough. Okay, so we have this validation logic that's going to occur, and we can rely on that working because again we have this subscriber context, right? So I can say context of key and value, and again you can put anything you want here, right? And then new byte, whatever, right? You can do anything you want, right? The point is just an arbitrary key value context, and that context is accessible at any point in time from within any point of the pipeline. And that's what we use behind the scenes to propagate the storage associated with the current ongoing transaction. And you can use it too, right? So anytime where you have a solution that might have called for a thread local, you can just use this. We use it all over the place though in Spring, where needed to support use cases for which you might have otherwise needed to use a thread local. So suppose you wanted to do transaction propagation. Well, of course, you can see that's already done for you. Suppose you wanted to do distributed tracing, where you propagate a context associated with the current request so that you can see the call graph thanks to the publishing of that call graph information to an out-of-band storage or tracing mechanism like Zipkin, right? Well, that's also very convenient. You can do that as well. We do that for you automatically using Spring Cloud Sleuth. Suppose you wanted to propagate the current authenticated user, the current authenticated principal. Again, same thing. It's taken care of for you with Spring Security and the context. We just do it for you. So all these places where you might have to use it, probably don't have to use it. Hopefully we've already done all these things that you're going to care about. But if we haven't, that mechanism is just as accessible to you as it is to us. Now, we restarted the code. Remember, I changed my name to be lowercase j, and I got my little error, right? The name must start with a capital letter. So if we inspect our data store, select all from reservation, 0 records, right? So it's atomically rolling back all of them, not just some. I can restart now, and we should see that we have all 8 records reflected in the output. So okay, I can hear you saying, great, we have data in the database, now what? Well, of course, let's build a let's build a REST endpoint, an HTTP endpoint. And we could, of course, just use the Spring MVC style. So we could say add REST controller, like so, class reservation REST controller. And this will give us just a very simple Spring MVC style endpoint, right? So get mapping /reservations, publisher of reservation, blah, 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 blah. And just inject the reservation repository. Okay, voila, good. And here is our dependency. So this dot reservation repository find all, and that works as well, right? That's fairly familiar territory if you've ever used Spring MVC. But keep in mind, this isn't Spring MVC. This is a brand new, net new reactive web runtime called Spring WebFlux. And there is no servlet API here. We're not using a traditional servlet container. We don't need to. We're building on top of Netty, N-E-T-T-Y, right? As a result, this is faster, more resource efficient, and just generally cooler, right? More lightweight, less RAM, less everything. So I like this style that I just showed you. I like this REST controller style. It has the benefit of being familiar, and if you have a number of different related endpoints, you can co-locate them in the same class, and they benefit from that aggregation, right? They're amortized over all the different endpoints that reuse this injected type, for example. Then the burden of having this class and the constructor and the annotations and all that other ceremony isn't so bad. That said, could we do better? Yeah, of course we could, right? So we could do this. We could actually create an endpoint, bean, router function, server response, and routes. Return route, build dot get / reservations. Okay, and I'm going to say, given a request, server response dot OK dot body, and we're going to inject here the reservation repository, RR, that find all reservation.class. There we go. So there's my new endpoint. And again, this is a builder API, so I can chain these things together if I wanted to, if I were so inclined. I can just put them all together, and reuse that. It's also dynamic. It's a builder API, so I can use if, else, while loops, all that other stuff to dynamically register these endpoints. Where I'm sure you, unless you're Raphael Winterfeld from ByteBuddy, for most of us, the proposition of dynamically adding methods to a class in a for loop, it just isn't as easy as we might think it is, right? It's just not going to be fun. Whereas here, we can just add these dynamically. So let's go to the browser, localhost, reservations, and there's our endpoint with our 8 records, okay? So great, I hear you say. It's 2020, and Josh just spent all this time showing me how to do 8 records in JSON from an HTTP endpoint and how to read and write data with transactions to a SQL database. Well, why, right? You could have done this yesterday with a servlet API, certainly. You could have done it with just JDBC or Hibernate or whatever, and that's a good point. I'm not yet trying to persuade you of the superiority of reactive APIs. What I want you to see is that we have achieved parity. I can do all the things that I would have done before with no more code. In fact, in some cases, less code. So let's remove that controller, and this is an initializer. It's good for our demo, but you're not going to do that every time, are you? Of course not. You're not going to do that in production. So realistically, here's the actual code. Here's my HTTP endpoint, such as it were. Here's my transactional service. Great. Here's my repository. That took no code at all. And here's my entity, right? So we're talking about almost no code at all to get all of this working. And it's just reactive APIs. The complexity lays not in the fact that it's reactive, but in the fact that we've written code. It's business logic, right? It's not more verbose or tedious than anything we would have done in a non-reactive world. And going a step further, we've got one kind of stuff. When I wanted to write data to the database, I use a reactive stream. If I wanted to do HTTP endpoints, again, I provide a reactive stream. If I want to do messaging with Kafka, I use a reactive stream. If I want to use messaging with RabbitMQ, I use a reactive stream. If I want to do application JSON, I use a reactive stream. Service and events, a reactive stream. WebSockets, a reactive stream. Do you understand? Everything is now just a reactive stream. This is ideal for composition. How many times have we written integration glue code where we want to take something from Kafka or RabbitMQ or whatever, this thing that is asynchronous, right? We're saying data is going to come here, and how do you process it? Well, there are as many ways, it seems like, as there are stars in the sky, right? I can register a message listener container and then have those messages delivered to me, right? And those message listener containers are different for each message queue, right? WebSockets, same thing for that. How do I create WebSockets in my different APIs? These APIs are all different, but they're all fundamentally trying to describe the fact that we have a stream of data that is eventually going to happen, but it's not here yet. It's not here right now. It's asynchronous. It's latent. It's potentially unbounded. Now we have just one way of describing that. We say that stream of latent, potentially unbounded, potentially infinite data is a reactive stream. If there's just 8 records in it, great. It's still a reactive stream. If it's infinite and it might happen 1 record now, 1 record next week, 1 record a year from now, it's also a reactive stream. life becomes much simpler once you've learned these reactive APIs, because now you have one kind of stuff. You can unlearn all those other APIs. Life becomes better. So good, right? Good stuff. But let's now talk about where reactive APIs really come into their own, to my mind, as a person who cares about production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. It's the happiest place on earth. It's better than Disneyland, and the weather is amazing. But if you have not been to production, you can begin your journey, of course, with Spring. And this is going to help you with that, particularly if production today is a highly dynamic, reactive, sort of evolving or potentially even volatile microservices-centric architecture, where, of course, one thing needs to communicate with another. So let's go to start.spring.io. Let's return to start.spring.io. And we're going to create now a client. And this client is going to require, it's going to support reactive web applications. It's going to use Lombok. It might use Spring Security. And it'll use RSocket. And of course, I'll use Java 15, which has finally, I can't believe I get to say this. It has multi-line Java strings, and it just works. It's so glorious. So we're going to build a client here, and this is going to be a thing that will talk to our service via HTTP. So here we go. Downloads UAO client.zip. Okay. Client application. Set up the JDK. I really need to just make this my default. Great. Okay, so I've got an application, and I want to make networked calls to that endpoint. So I'll use the reactive non-blocking web client. And the web client is an HTTP client. It's kind of like the venerable REST template, except that it's non-blocking. So I can make all sorts of different network requests, and while I'm waiting for the bytes to return from the service to which I've made those requests, I'm not keeping a thread monopolized, okay? And then having done that, I'm going to create a bean of type application listener, again, just to listen for an event. Readiness, right? And here I'll say HTTP client listener, and I'll use my web client, HTTP, return event. Okay, and all I'm going to do, I'm going to say http.get.uri, HTTP localhost 880, and I'll make a call. I'll say reservations.retrieve, and I want the data that comes back, the JSON data that comes back, I want that to be a reactive stream of reservations. So I'll return to my service implementation here, and I'll take the type that I care about here, the reservation type. I'm going to copy and paste that. Okay, so I'll say reservation.class. Oops. With that, reservation.class, and I get back a reactive stream of reservations. Now this reactive stream of reservations is being made, it's data I'm getting from making a network request. That data is going over the wire, and I'm getting the response back. Is that going to always work? Is that going to always work with impunity, no problems whatsoever, ever? Well, of course not, right? Things are going to fail. Obviously, I could and should, hopefully, be doing something to load balance this call, right? If you're using Spring Cloud and the Discovery client, then you can get smart client-side load balancing by talking to a service registry, something like Eureka or Apache Zookeeper or etcd or Cloud Foundry or Kubernetes itself. You know, the Kubernetes API can be a service registry, or I can talk to Apache Zookeeper or HashiCorp Console. I mean, there's all sorts of different service registries. These are kind of like phone books for the cloud. You give them a service ID, you know, the reservation-service or the customer-service, and it'll give you back all the hosts and ports on which that service lives, right? And you can then direct your request to one of those nodes based on some sort of load balancing algorithm that you run in the Java code on the client. Alternatively, you could also use a load balancer, right? So obviously Kubernetes has the ability to create a load balancer for your service, Cloud Foundry as well, right? Also Heroku as well. They can all do load balancing on the service. That's fine. All sorts of different choices there, all sorts of different options. I'm happy with all of them. Let's assume that we don't have that, or that we've done that and there's still an error, right? Let's assume that we've already done load balancing, we got a response, we got a node back, we're making a request, and we still got an error. What can I do to make this a little bit more robust? Well, I can retry. I can retry 10 times. I can retry 10 times and back off, right? 10 times. I want to back off for a progressively longer amount of time for each one. I can also prescribe an on-error resume callback. So I can say, okay, if there's an illegal access error, then whenever there's an exception of that type, I can control what I return. I might return a new runtime exception, right? Or I might just return a default value. I can say empty, right? And this is graceful degradation. I'm actually, and by the way, you can just do this. Or for that matter, if you just want everything, you can also do that, right? That works as well. But what I'm doing is I'm gracefully degrading. When you build microservices, it's important that you care about the graceful degradation use case. If I have one service talking to another, I want to make sure that I do the right thing in the case of service outages, topology failures, etc., topology changes and failures, etc. It's very important that I degrade gracefully. High-performing organizations do this kind of thing all the time. They'll say, hey, you tried to call the search engine service, but it's not available right now. Here are some machine-learned recommendations from across the web, or perhaps here's your favorite list. Would you like to inspect that? And hopefully the user doesn't even know that they're missing anything. Or at the very worst, they're still able to move forward. It's not exactly what they wanted, but it's better than nothing. It's certainly better than an ASCII art middle finger embedded inside of a giant stack trace, right? Much better than that. So is that okay? Is that enough? I think that's pretty good. But what if this thing blocks? What if I make a network call and that service just isn't responding? It won't hang up, but it won't give me a response either. Well, naturally, that might jeopardize my SLA, right? I want to make sure that if I commit to an SLA for my client, that I actually deliver within a certain bound, a certain period of time. And so I can specify a timeout. Now, this is a ridiculously indulgent, oh so indulgent timeout. 10 seconds, that's an eternity. It's an eternity. But just bear with me here. Suppose I could actually maintain an SLA, or I was privileged enough, I was lucky enough to have an SLA of 10 seconds. 10 seconds is, as I say, an eternity. That means that I'm going to make a call to this downstream service, and I don't expect a response in less than 10 seconds. What does it say about my SLA, the SLA that I, as a service, must maintain for the thing that's calling me? Well, I must have an SLA of at least 20 seconds, right? Because the reason you use a timeout is to create an upper bound. But what's the point of an upper bound if it doesn't give you enough of a window to try the request again? So you must assume for every SLA that you see for a downstream service, there's an upstream SLA that's at least 2x whatever you use downstream, right? And so this number, of course, is bad because it decays very quickly. So I make a call to the downstream service and I give it 10 seconds. That means that in practice, if that thing needs to make another call to some other service, then it needs to respond within 5 seconds, right? And if that thing makes yet another call to another service, then that thing needs to respond within 2.5 seconds. You see the problem? The downstream services have a more and more unforgiving timeline or timeout, based entirely on the proximity of the node to the origin of the request. Seems very unfair, right? And it's not very effective, and it's untenable. Obviously, it doesn't scale more than a few hops down the chain. So what can we do to simplify things? Well, there are a lot of patterns that we can embrace in the reactive world that would be very difficult to get right without reactive APIs. One of them is called hedging, right? You hedge your bets. You don't want to put all your eggs in one basket. You've heard common aphorisms like this, right? Received wisdom. And they make a lot of sense. We all understand the idea. You diversify the risk so that if something should fail, you haven't lost everything. You've just lost that one particular option. This is true in life, in gambling, and investment, and in services, in microservices. So what I want to do is I want to diversify the risk. I don't want to bet on whatever's on host and port localhost 8080. I want to bet on, I'm going to diversify the risk. I'm going to launch the same request to 3 discrete instances, 3 different services. And whichever instance should return first, I'll keep that stream and I'll apply back pressure to the other two. So suppose I have a Spring Cloud Discovery client on the class path. I'm using the Discovery client, and I'm programmatically discovering 3 different host imports. Okay, I'm asking for a subset of all the different registered instances. I might have 10 instances of the service in the load balancer, but I want to just pick, 2 or 3, some number greater than 1, right? N greater than 1. Then I want to load balance between those 2. But in order to guarantee that I get a response, I just launch the same request to all 3 or all 2 of them or whatever. That way, even if one of them is down or garbage collecting or whatever, surely the other one will be able to get me a response in time. So I'm reducing the risk considerably. And what I want to do is I want to launch these things in concurrence. I want them to launch at the same time, all 3 of them, in flight to 3 different discrete host imports. And whichever should return the first byte first, I keep that one and I automatically apply back pressure to cancel the other 2. Well, of course, this is inherently complicated, very threaded code, right? It's not the kind of threaded code that I want to write. It shouldn't be the threaded code that you want to write. It would be verbose, if nothing else, and also very error-prone. Remember, friends, only one person truly understands how to write effective multi-threaded Java code, and it's not you. It doesn't matter who it is. I don't know who it is. I just know it's not me and it's not you. Don't write Java threaded code. It's not a great idea. I saw a great quote the other day. Just made me smile. The designers of the Lua programming language said that when they were designing it, they realized that any language where A equals A plus 1 isn't deterministic is inherently problematic, right? And this is the situation we find ourselves in with threads in the Java ecosystem. We get around that not by abandoning threads, but by putting guardrails around them. These reactive APIs give us those guardrails. So that's what it looks like. Let's see what it looks like to actually implement hedging. Let's suppose I'm going to make a call to host 1 and host 2 and host 3. And of course, I'll leave it to your imagination to imagine how we've just copied and pasted this endpoint and changed it to host 1 and then host 2 and host 3, right? 3 different hosts. Now I've got all 3 reactive streams. But remember, we haven't subscribed to anything yet. And remember what I told you earlier, nothing gets conducted through the pipeline unless you subscribe. Okay, so now I've got all 3 streams. So now I'm going to say flux.first, host 1, host 2, and host 3. That's it. That's the entire implementation, right? That's going to pick, whichever one starts emitting a value asynchronously first, we'll keep that one. And we'll apply, this will also apply back pressure to the others. Great, right? Really, really convenient. We're done that. So, so now we have this very,
sorry to interrupt, but we actually have a lot of questions coming from our audience. So if you could,
can we let me wrap up this point and we'll take a brief break for the questions and I'll just try and finish. Actually, where are we doing? What do we? How much time do we have? 8 minutes. Good gravy. Let's see.
Okay, you can complete this. If you have time, we can extend the questions after the schedule.
Time. I'm here for you. Absolutely.
That's awesome. Okay.
Give me a minute. So we've used hedging to make this call. No, but not a big deal. Very natural pattern to do in the reactive world. I like this approach. The other thing is when you use reactive APIs, you have the ability to do scatter, gather, sort of service orchestration and composition, right? So the idea is if you have a lot of different microservices and you're trying to present a view of the data, but in order to do so, you need to aggregate data from different services, from service A, service B, service C, and you want to get them all into one aggregate type, right? So let's, again, using some examples here, just some pretend code. Let's say I've got an entity called customer, and it in turn has an ID and a name. And again, I'm not going to go through the paces of actually making this real code, not really code. And let's suppose that I've got a order type, and it's got an ID, and it's got a pointer to the customer ID. So it's a one-to-many relationship, right? And I want an all-args constructor there. And let's suppose I then have a client that I can use to talk to these different microservices. One is called the order service, and the other one is called the customer service. So I can say, give me the orders for this string customer ID, right? And then I've got another endpoint here that'll return a stream of customers, and I can just say, give me all the customers. And what I want to do is I want to call those two different services, one at the same time as the other, and return an aggregate type called customer orders. It's a view of the different data. But remember, in the microservices world, each service maintains its own database. So it's very important that the only way you talk to that service be through the unified interface, the API, right? The HTTP endpoint, whatever, right? So I'm going to have here a customer and a list of order objects, right? Here we go. So there's my aggregate type, LRX constructor. Now, what would it look like to use this client interface to make calls to these two downstream services? Well, again, using our imagination here, I leave it to you to imagine what it looks like to implement that interface. It wouldn't be all that hard, right? It would surely look like this, but with different host imports and different domain types. And then I want to say, okay, given that, I want to get all of the customers. So I've got now a map of customers, or a publisher rather of customers. And what I want to do is I want to visit each one of those customers. And for each customer, I want to also get all of the data for the orders. So for each customer, I want to get the customer orders. Well, now I've got a different, I can't just map, right? Because if I map, then suddenly the type of the thing becomes the new thing instead of the old thing. I need the old thing still, but I also want the new thing. So a very common pattern is to use zip. What zip does is it zips things together, right? So I can actually say, okay, the idea behind zip is that it takes one reactive stream and another reactive stream, and it waits for each one to emit a value. And as soon as the left one and the right one have emitted a value, it aggregates that into a new type called a tuple, right? A tuple is a very common term from other languages. We don't really hear it in the Java world. But here I'm going to create two streams, one containing my customer and another containing all the data from the CRM client for the orders for this customer, right? So I'll say customer.id. And that's the reactive stream of data here. You can see it's a tuple of customers to orders. Actually, what I have here is a tuple of customers to order. I don't want a single order. I want all of the orders. And so remember what this returns for me. This gives me a flux. So I want to collect all those things into a list. So now what I have, friends, is a publisher of publisher to tuple to customer to list of orders. Well, again, see what we did? We have to unpack that using flat mapped. Okay, so there we go. Now it's gotten a little bit cleaner. Now it's a little bit easier to understand. Now we have a reactive stream of tuples. And a tuple has one thing on the left, which is the customer, and another thing on the right, or one thing in the first place and another thing in the second place. So what I want to do is I want to take each one of those, I want to turn it into a map of customer orders. So results.map tuple into a new custom orders, right? And I pass in tuple.get T1. T1 is the customer. Tuple.get T2. That's the list of orders. There we go. So now I've got my aggregate type. And that's the thing I can actually return to the client, right? So again, there's no threading in this code, and yet I've gotten very efficient multi-threaded code here. Because think about what I'm doing here. I'm actually making a call. I've got the n+1 problem, right? This is an unfortunate situation to be in if you're writing microservices code. Ideally, you'll have two different endpoints like this, where you can actually, or better yet, you can actually get all the data for all of the different things in the outer collection, in the subordinate collection, right? That'd be nice if you could do that. It'd be nice to say, give me all the orders for all of these customers. That's great. If you can do that, great. That's even better. Build that endpoint, and that becomes even more trivial to implement, right? But in this case, we have the n+1 problem, where for every customer n, we have to, for every customer, we have to make a call to get all the other orders, right? That would be problematic, especially if it's serialized one after the other. But because this is a reactive API, what this is going to do is it's going to fan out, launch all the requests in concurrence, and then aggregate them into a result. So you'll get them hopefully, hopefully you don't have a billion customers, but even if you did, it'll still be way faster doing it this way than if you tried to do all billion in serialization, in a serialized way, right? So these kinds of patterns become much more trivial to express in a reactive world, my friends. Let's see here. If we run this, reservation.flux, subscribe, system out, print line. Voila. So let's run this. We'll see the HTTP endpoint working. Oh, port 8080 is already in use. Of course it is. Server.port 0. I don't care about the port. I just want the reactive non-blocking HTTP client. All right, friends, there we are. There's my 8 records. It worked. We were able to call the other service and so on. And we've looked at a number of different patterns that you can use to build more reliable, more robust services. We also looked at how Reactive APIs makes using different endpoints, different services, different technologies easier because, again, you have fewer types of APIs to learn, and you have and more to the point, you have just one API to learn, which, when it comes to composition and orchestration, makes things much easier. Actually, we're out of time, I guess, and I would love to show you RSocket. RSocket is a binary protocol that was forged in the fires of production at Netflix and Facebook. It is natively reactive on the wire. That is to say, it has back pressure in the protocol level. Remember, HTTP does not have this, right? When a client disconnects from a reactive HTTP endpoint, the best that reactive HTTP endpoint can do is to perceive that disconnect and then cancel everything. That's it. It's not possible for a reactive client to connect to a reactive HTTP endpoint, ask for 10 records, and then just not ask for anything for an hour, and then ask for more. That would be session resumption, right? You don't have that with HTTP. Data in, data out. There's no such thing as a cursor, basically. So that's not great, right? HTTP is also very limited. It supports only request and response. It doesn't support other more flexible messaging exchange patterns, things like fire and forget, things like streaming, or things like true bidirectional communication. HTTP 1.0, not 2.0, but 1.0 is also not. It also doesn't support multiplexed communication on the same socket. So each time you connect, you have to open up a new socket, connect, do the handshake, get the response, and then disconnect. Right? Very slow. With RSocket, everything is multiplexed. You can share one single socket. So there's just all sorts of stuff that make RSocket much more efficient. And there's a reason why organizations like Netflix, like Facebook, and like Alibaba are using RSocket. The RSocket Java client uses Project Reactor. And so we were very impressed by this and by what people were doing with it. So we built it into Spring itself. So while I don't have a lot of time to show you all about it, and much as I would love to, I want to encourage you to find my YouTube video called The RSocket Revolution. And you can see there's a whole like 45 minutes on it. But what we need to know is this is just going to be an RSocket controller. Okay, so I'm going to take my Reservation RSocket controller, and I'm going to inject my Reservation repository. And as before, and by the way, I'm back in the service here. And I'm going to create a message mapping, reservations, publisher of reservation, turn this reservation repository, find all. So there's that on the server side. It's a controller, but I'm using message mapping, not get mapping, not request mapping, message mapping, right? And the only other bit that I need to do is I need to configure a port on which to run the RSocket endpoint. Now I go back to my client, comment this out so we don't get confused by the output, right? Create a new application listener, application ready event, RSocket client listener. And in order to do our work, we need a RSocket requester. So event RSocket requester at bean RSocket requester.builder RSocket builder. Good. So we say builder, and notice that we're going to specify the host and the port because, like I said, once the application starts up, you connect and you stay connected, right? You can retry if something goes wrong to reconnect and so on. There's all sorts of support there, but the point is you don't have to reconnect each request or each transaction. Okay, dot route we called it reservations, right? And the data that I expected back is a stream of reservation. And I'm just going to log out the results, just as before. Okay. There's the same data. And there's also a very nice client you can use. It's kind of like it's like a curl for RSocket. It's called RSC. So here I'm going to say stream, and the route is called reservations, and the endpoint is localhost 8888. And there's the data. I hope, my friend, that you've begun to see the possibilities here. I hope I haven't failed the incredible opportunity that reactive programming represents. I hope that you learned something from it. I'm sure that there are a lot of other more interesting places you could have been this morning, and I really, really appreciate you all taking the time to be here with me instead, and I'm grateful for that, and I wish we could all be together. Obviously, I wish all of you a great, good day, and I hope you're healthy and happy and safe, and I'm very happy now to answer questions.
Thank you, Josh. Sorry for the time limit. We are running out of time, and any successful meetup actually is the one that gets a lot of questions, and we sure have a lot of questions. So I'll just go through the questions one by one.
Sure,
the first question we have is it recommended to learn Spring MVC before learning Spring Boot for a new Java learner, or starting with Spring Boot is fine? This is not particularly related to Reactive.
So Spring, yeah, I would learn Spring Boot first, right? Spring Boot that's where you want to start, because Spring Boot it's an integration of a number of technologies that make working with Java easier. So Spring MVC is but one of those. It's a very tiny subset, right?
Right. Another question that we have from a lot of people is, where can we learn actually all of these monoflux subscriber and all the reactive programming things in Spring and Spring Boot? Can you share some resources?
Yes, absolutely. So spring.io/guides, right? There's some resources there. Obviously, if you go to the Project Reactor website, projectreactor.io, I think, that also has great resources as well for all the details of Flux and Mono and so on. And where else would you go? Where else would you go? The documentation, of course, is impeccable, right? It's exhaustive, but it's there. And you know, there's plenty of videos. Every Spring 1, we have all these videos, hundreds of videos that go up online. So you'll find no shortage of content, including some by yours truly. Those are definitely not the best, but they're out there, right? And reactive programming in general, the thing is, because they're using these reactive streams types, if you learn reactive programming in terms of RxJava for Android or Arca streams in Scala, it doesn't matter, right? These things are interchangeable. I actually did a video where I demonstrated using Scala and Arca streams and Spring WebFlux. They can interoperate, no problem, right? I can use these things together. The other opportunity that I didn't even begin to have time to be able to show you, but if you understand everything that we've just covered, and if it's sort of in your head, you kind of understand what's happening in the background, then there's a really interesting opportunity in Kotlin coroutines. So Kotlin's coroutines give you the ability to write seemingly imperative code without having to change the way that you write the code, right? It looks like step 1, step 2, step 3, as opposed to one long streamed fluid DSL like I had to do here, right? And behind the scenes, at every point when you are doing something asynchronous, the compiler rewrites the code so that it actually breaks up the method that's containing that asynchronous invocation, and it then relinquishes the thread while you're waiting for that asynchronous thing to come back to you. So other languages, like literally every other language except for Java, calls it async await. So any language that has async await will be able to, for example, whenever you have a future or a promise or anything like that, it'll allow you to say that this call is an async function, and then when you invoke that async function, you say, I want to await space that result, right? In Kotlin, it's not called async await, it's called suspend, a suspend function, and there's no await keyword, but the effect is basically the same. And so you get this really consistent, really concise data flow code. And when you use reactive APIs through Spring and through Reactor with Kotlin, all of our APIs automatically work as coroutines. So everything you learned about in Spring for WebFlux and security and for messaging and for HTTP, all of that, now you can just start using the coroutine equivalents, and that all builds, it actually uses all of our reactive APIs. So you get the same benefits without having to,
Right.
your data flow life.
Right. So next question we have is how to migrate from a non-reactive application to a reactive one. Do you have any pointers for these?
This part's not easy. So again, there's nothing technically stopping you from co-locating reactive code and non-reactive code into the same JVM code base. Where you get into trouble is when you want to do something not reactive inside of a reactive pipeline, right? So if I want to call another service and I have a client that is it's gonna block and it's gonna keep my IO, then I need to make sure that I do that on a separate thread. There's an operator on these reactive streams types on Flux and on Mono called subscribe on and another one called publish on. And basically in those methods you pass in a scheduler. We didn't get to look at a scheduler because you don't really need to know about schedulers. But schedulers are 1/2 timekeeper and 1/2 thread pool. All they do is move work from one thread to another. And you don't normally need to interact with them unless you're doing something not reactive. If you want to do something not reactive, you need to make sure that you get off of the main reactive thread pool. Because remember, the normal thread pool for reactive APIs, the default one, has 1 thread per core of your machine, 1 CPU core. So if you've got 4 cores, you've only got 4 threads. And this is more than fine to handle millions of requests if you're not doing if you're doing reactive calls. But if you're doing non-reactive calls and you block one of those 4 threads, you're not just blocking one user's thread, you're blocking 25% of all your users' threads, right? So it's imperative that you never do that. You always be very judicious about moving to a separate thread pool, a separate scheduler, right? And this has always been true, by the way. Whether you're doing reactive APIs or not, we've always been required to understand on what thread pool our work is happening, right? This is why people move work from the front end selector web thread pool in their web apps to a back end thread pool. This is why people use messaging so they can move it to another computer because they want to let that computer with its own thread pool do the work, right? There's all sorts of things that we need to care about. It's just now we have the explicit tools to make that decision more upfront and explicit, right? That's the important part here. We've always had that privilege. It's just now easier to do. So when it comes to moving to this, first of all, in terms of types, you can get away with a surprising amount of things in Spring WebFlux. You can see that the annotations are the same for a lot of stuff, not all of it, right? But a lot of things like at-rest controller and so on, all of that works. And in fact, you can even return, you can have a handler method that returns a collection, not a flux, right? Or a single string, and you don't have to wrap it in a mono. So for a lot of your controllers, we'll just make it work for you behind the scenes. We'll take your return value and adapt it into a mono of t, where t is the return value that you were going to return normally, right? So we do a lot of that stuff for you. That's not going to be so painful. Where I suspect you'll find some pain is when you start trying to do, trying to mix these things together, like I said, with the schedulers, right? That's the first thing. And the other thing is whenever you're doing something low level with servlets or filters, right? Where before you might have had a servlet registration bean, there's no servlet anymore, right? It's not going to be great. That said, there's a nice thing here. In Spring WebFlux, we can make Spring WebFlux work after a fashion on Apache Tomcat and a few others, right? So servlet containers. It's not completely reactive end-to-end, but you can write reactive code on top of the servlet code base. And in theory, you could actually have these, you could still have your servlets and then also have your reactive stuff. I haven't tried that, but that's the idea, specifically to support that migration use case. But I would try and get to Netty as fast as I could, right? That would be my goal. Is there anything else? I hope question.
That we have is, are there any limitations of using Reactive Spring? And
Yes.
along, I'll just add another question along with this. Can you shed some light on debugging reactive streams?
Yes, so limitations. If you're doing primarily computational or CPU-bound work, then this isn't going to work for you, right? I spoke to that earlier when we first started. I said that CPU-bound work is still CPU-bound work. There's nothing you can do to avoid that. You can't rub reactive on it and make it go away, right? It just doesn't work that way. Where we benefit from reactive programming is when we do work that, for the moment, is I/O-bound. If you're doing CPU-bound work, like I said, just think of anything that sits on the CPU. So cryptography, right? That's a great example. Security, anytime you're doing encryption or decoding of a password or something like that, that's going to sit on the CPU. You don't benefit from reactive APIs from that. So yeah, I would if that's all you're doing and you have no input and output, and that input and output is very short-lived, don't bother. It's fine. Yeah, like that's not their issue. And by the way, keep in mind, if your only use case is your scalability, if that's the only thing you're trying to solve, we've already had a half step that's available, and it still is available, that's been around for 13 years, which is the cloud, right? If I'm trying to have the ability to address more users, then I can just put my application behind a load balancer, pay Amazon or Google or Microsoft or whoever, or Alibaba or whoever, and I can just scale that horizontally, assuming you've built an architecture that benefits from horizontal scaling. Hopefully you're doing microservices and so on. But if you are, then hey, maybe that's cheaper for you than trying to wrap your head around and then embrace fully in the code base these reactive concepts, right? And then the second question was how to debug. Now, when you debug reactive applications, first of all, the basic tools of the trade still work. You can put a breakpoint in IntelliJ or Eclipse and just watch the stack, right? That's fine. The other thing is there's a library called the Reactor Tools library. You add that to the class path, and it'll give you a couple things. One is there's a tool that will let you, at compile time, enrich the stack that's being built up around these pipelines. And so if there's an error, you can actually ask for not a stack trace, but what's called an assembly trace. And the assembly trace represents the sort of the history of the request from one thread to another. Because remember, stack traces are bound by threads. They're per thread. There's no such thing as a stack trace across multiple threads, right? So this actually gives you that view of the error from across different threads, which is, we call it assembly trace. But that's expensive, right? So there's one way to do that without this compilation process, where you can say hooks, capital H, hooks dot on operator debug. It'll automatically capture that for you, but that's expensive at runtime. You can use the compilation mechanism, and that's much faster, but it's still extra overhead, right? To accumulate and capture all the stuff, it still takes more RAM and more time. So I consider these both a development time tool, not a runtime tool for production. There's also Blockhound. Blockhound is also part of Project Reactor. Go to the Reactor GitHub organization. You'll find Blockhound there. It's a Java agent. You literally just add it to the class path. You call blockhound.install in your public static void main before you kick off Spring Boot, right? Spring application.run happens on the line after that. And anytime you do anything that blocks a thread inadvertently, it'll throw an exception. So if you do something silly like thread.sleep, or you do cryptography or Fibonacci or anything like that, where you're unfairly monopolizing one of those threads that you should be relinquishing for the reactive runtime, it'll automatically throw an exception for you. So it'll help you ferret out any of these inadvertent things that are starving your very, very limited thread pool. What else? Oh, there's an operator there called log. So whenever you create a reactive pipeline, you can say .log and put a little string in there like label, and it'll actually print out when it's gotten to that point, right? So you can see in the pipeline what the state of things look like at a particular juncture. I hope that helps. And also, if that doesn't help, I also did a Spring Tips video called Debugging Reactive Applications.
Yeah. So Josh, how much time do you have left?
About an hour and 15 minutes.
Okay, so we have plenty.
I'm done with my talk, but I'm saying I don't have to be anywhere.
Okay, after this, even just for the questions, are you running late for something, or we can just continue with the questions?
We can just continue. I'm not in a hurry, like I said.
Okay. So the next question we have is, are filters and interceptors still relevant in reactive context?
Yes. Yeah, absolutely. Yes, let me see if I can. So hold on, give me a second. I will find that for you. Reactive Spring book. There's a GitHub repository, a GitHub organization called Reactive Spring Book, and that's all the it's open source. It's the code from my last book, and lots of stuff there, lots of examples. You might try that if you want examples on, more in-depth examples. If you don't want to buy the book, I don't blame you. There's a lot of good stuff here, and let's see here. Filters. Okay, so may I show my screen? Okay, share my screen, present. All right, so lowercase web filter. This is an example in the, so you just create a web filter, and the API is, I think, fairly recognizable, right? Given
but your screen is not showing up if you are trying to share the screen.
Oh, awkward. Sorry about that. Better?
Yeah.
Okay. So here's an example of a filter. It's just a regular Spring Bean, and I assume that this looks fairly familiar if you've ever used a servlet filter. It's a web filter, but given a current request, and I have a chain, I can do something with the current request. I can get the attributes, do whatever, and then I can modify. I can mutate the current request, which creates a new request. It creates a new object, and I can send that down the chain for other filters in the chain to process. So it's not the servlet API filter, but it looks very similar for obvious reasons. Okay, that's this one. You can also, let's see here. You can also provide a dot filter here. Like you can actually do dot filter, dot before, all these kinds of life cycle callbacks. When you create a functional reactive HTTP endpoint, you get these nice convenient little opportunities to log out things before and so on. This is kind of like your general purpose, before and after, right? Whereas this only shows you the request before the request has happened, and this only shows you it after the request has happened, right? And of course, there's these callbacks on error and so on, like that I showed you before. And what else is there? Error handling. Yeah, I think that's it. Those are the two channels: is the dot filter and the web filter API. I hope that answers your question.
Okay. Next question we have is, in case of Flux, could we have any number of records? And if there's any support for pagination to avoid performance issues while requesting REST APIs?
So when you're calling a downstream service, there's nothing built in to a Flux, right? You can actually, it's an HTTP call. So if you want to build paging into that, you can, right? The only thing is, if you're, let's say you're returning a service and event stream or a WebSocket stream or something like that. With service and events, you can consume data as it's being emitted, but you can also push back. That's not pagination, though. There's no ability to go backwards there. You're just back pressure when there's too much data, right? So, you can't just do unlimited data. That's not the case, right?
Right. Next question we have is, how reactive programming is different from JMS processing. Could you please explain?
Sure. So JMS is it's an API that completely ignores the point of messaging, right? JMS was designed to give us a standard interface that allows us to describe a message queue. So reactive APIs don't imply a message queue. Reactive APIs give us a way to deal with data, even in the same virtual machine, right? You don't have to have distribution for this to be useful. I showed you HTTP and RSocket and so on, but I also showed you just creating a reactive stream in the same virtual machine, right? One consumer in the same virtual machine talking to another. They can use reactive stream types. So there's a protocol there that can be expressed over the network or on the same machine. JMS is a message queue, and actually, no, I'm sorry, it implies a message queue. It's a very bad API. I don't know how to be polite about it. It's the worst API for messaging out there in the world of messaging, right? Think about what you're trying to do with messaging. You're trying to decouple one side from the other. So you have a producer and you have a consumer. The producer sends data to the consumer, right? Where do they send it? Well, they send it to a destination. So you can see those two sides reflected in the JMS API, javax.jms. I think it's producer and consumer, actually, I'm pretty sure. And then you have a javax.jms destination, of which there are two specializations, queue and topic. A queue is point-to-point, a topic is broadcast. And this is a very simple routing, a very simple agreement, right? Send data to a destination, and then the consumer consumes from the destination. The problem is, messaging is all about decoupling. So how have they built this API which forces you to couple in so many unnecessary points? First of all, why would my consumer and my producer need to agree on the same destination? That's not all message buses have the ability to reroute things in the bus, in the broker. So the message may arrive at one place, but before it gets delivered to the consumer, waiting for it on the other side, it gets moved somewhere else in the broker itself. They don't share the same destination. That's coupling, right? I want to be able to say, send it to this building, but it might get sent to the mail room and sent up to another room, another part of the office in that building, right? We both don't need to wait in the mail room for a conversation to happen, right? That's what's happening with JMS API. So all other protocols, all other technologies for messaging have the flexibility to have indirection between where the message is sent and where it gets consumed. That's the first thing. That's one kind of coupling. The other thing that's really awkward about it is that JMS is a Java API. And I love Java. I love the JVM. But it's arrogant to assume that Java is the only API out there for writing messaging code. It's just not the case. Would that it were, right? And so when you write Java, when you use JMS, each JMS driver or client has its own Java API, and each one speaks its own protocol with the broker. Well, that means that if I update the broker, I now need to update both producer and consumer, because the client might break. I have to force a flag day upgrade to upgrade the client and the service. That's ridiculous. It's the whole point, is I want to have the ability to decouple one from the other, right? It's obscene. I can't believe this is a situation that we have found ourselves in 20 years of messaging, or sorry, 60 years of messaging. I can't believe they built the JMS API. It just makes me sad here in my heart. It's up there with PHP, and I can't even think of what else. It's just really, it's a sin against programmers, you know? I can't believe we have such a bad API. So anyway, that's nothing to do with Reactive. I don't recommend JMS. I wholly discourage it. If you can get rid of it, do. It doesn't support reactive programming. I don't want it to. It's just blows my mind. Use something else. Use Kafka or Kestrel or RabbitMQ or literally anything. I mean, there's literally dozens of other ones that are better. So use that. And you can use Kafka or RabbitMQ with reactive APIs, by the way. That's nice, right? Much better.
Right. So Josh, we are actually running out of time, and we have a lot of other questions. So I will request everyone whose question has not been answered to ping Josh directly on Twitter.
Oh dear.
Is that okay? Is that okay for you?
Mm-hmm. Of course. Oh, look at this! Somebody cool. Somebody posted an article on DynamoDB with AWS DynamoDB and Spring WebFlux. That's cool. I will look at that. Oh my goodness. How is rate limiting controlled? Great question. Check out Resilience for J. Resilience for J gives you a rate limiter. It's reactive. It supports reactive APIs. Or you can use Spring Cloud Gateway, which is also a reactive API gateway that has a built-in rate limiting filter. Where can you learn more on MonoFlux and Subscriber? Check out Project Reactor. How does event loop handle the request and response in Reactor? It's an event loop. When the request comes in, it puts a task on the queue. Something in the event loop picks it up. If there's any blocking, if there's any I/O that gets happened, then the task gets put back on the queue. There's a callback or registered, and it gets picked up again when there's data that comes back. How to get the hook of user principal coming in from Spring Security with the REST API? You can just inject the user principal, right? You can actually use @authenticated principal and inject it just like regular Spring Security. Can you please explain the usage of RSocket? Yeah, check out my RSocket video. It's called the RSocket Revolution. It just came out like a month ago, and people really liked it because it's awesome. Not my video, RSocket's awesome. In case of Flux, We could have any number of records. Is there any support of pagination to avoid? I already talked about that. Debugging streams while performing service communication. Usually we use response to write, download large files. Oh, that's a very specific question. You're talking about how to send files out. Ping me offline. That's like a separate thing. I'll connect you with Arjen Poutsma, who's actually been working on the multi-part file upload and download support. Thanks. Thank you for the set. No problem. Thank you. Did I miss anything else? Is this going to be recorded? That's a very useful thing.
Yes. Yeah, this is being recorded.
Okay. Is it possible to use gRPC protocol buffs with Spring WebFlux? Yeah, I think so. There's actually, go to github.com, Spring projects experimental with hyphens in between, and we've got new support for gRPC. I don't know if that implies reactive, but you can also use the gRPC compiler plugin from Salesforce. So look, go, Salesforce, the big company, they have, go to their github.com project. They have a gRPC Protalk compiler plugin that generates reactor-based services instead of using the regular default async protocol gRPC services. There you go. Okay, I think we got to most of the questions. I'm happy to engage afterwards and answer them offline. I appreciate it, everybody. Thank you so much for your time.
Thank you, Josh, for your time, and I'm hoping that we will be continuing this session in another session later.
That'd be great. I would love to. Let's meet again.
Okay. Is that a yes?
Sorry?
Is that a yes for another meetup?
Oh, I would love to do another meeting, like I said, and hopefully in person, but I'll do another one virtually, of course. Please, yeah. You have no idea how sad it makes me. I haven't been to New Delhi in a couple of years, and it just, I'm so hungry now.
Thank you so much, Josh. That was an amazing session as usual. And I was just looking at your Twitter handle, and you have another 4 sessions to go today. Oh my God, how do you do that?
Well, a little bit of caffeine. It's just, I'm going to be, there's all these Google Developer Group events from here until like noon tomorrow. So it's 11 o'clock my time, as you can see. And I've got presentations that last until noon. Oh, well.
You are a rock star. Thank you so much, and all the best to you.
That's high praise from you, my friend. Thank you so much. It's very kind. And all the best to all of you as well. And to you.
Thank you, Josh.
Thanks, Josh.
Thanks.
Thank you.
Thank you, Josh.
Bye. Cheers.
Thanks, everyone, for joining. And yeah, feel free to follow us here. And yeah, let us know if any other sessions you like us to arrange. We'll try to find the best in the industry and try to have that session. Thanks a lot. And thanks our community partners for bringing everyone here for a great session from Josh. And thank you, Josh.
My pleasure. Thank you.
All right.